Hi guys, it's Mrs. Kerr again. So I'm going to be doing your second factoring review with you for the week. And today we're going to be reviewing how to factor trinomials and how to factor the difference of squares. Okay, so we're going to start with the difference of squares. So if you remember, we just kind of had the formula or whatever that told us if we have two things that are subtracted that are squared. Okay, so as an example, if we have a squared minus b squared, this will always factor into a minus b times a plus b. Okay, and we can prove that by distributing. So if we go and distribute here, right, I'd have a squared, and I'd have plus ab and minus ab. So the middle terms would cancel out, and then minus b squared. Okay, so just remember, one is always a minus and one is always a plus to get that middle term to cancel. And then just as a reminder, you can only factor the difference of squares, not the sum. So a squared plus b squared, you might think, oh, that will just factor into a plus b times a plus b. Well, this will not work. And the reason it won't work, if you go to multiply it out, you'll see that the middle term would not cancel out. You'd have a plus ab and another plus ab. So it's only unique to the difference of squares. You cannot factor the sum of squares. And just as a reminder, since we are continuing on factoring, before we use any other factoring strategy, we're always going to look for greatest common factor first. All right, so let's do a couple of examples of difference of squares. So our first example is we're going to factor 16x squared minus 25y squared. So first I look for a greatest common factor. 16 and 25 don't have anything in common. There's no variables in common. So how I can recognize is this the difference of squares is, first of all, it's a difference. It has to be two terms. This is a difference. It's got two terms, and I have to be able to take the square root of each term. So sometimes I even write that off to the side. So the square root of the first term, 16x squared, is 4x. And the square root of 25y squared is 5y. Okay, so once I've recognized that it's the difference of squares, I go ahead and take the square root of each term, and then I set up my parentheses. Okay, and then from there, I'm just going to follow the formula. Put my numbers in there. One is minus, one is plus. So my one factor is going to be 4x minus 5y, and my next factor is 4x plus 5y. Okay. And it doesn't matter. You can change the order if you want. You could do the 4x plus 5y first. Okay, so anytime you're factoring, the two factors are always interchangeable. If you weren't sure if you did it correctly, guess what? You can just check by distributing. And notice here we'd have 16x squared, and then the middle terms would wind up canceling, and then we'd have minus 25y squared. Okay. All right, let's do one more of the difference of squares. So this one is 12x squared y minus 27y cubed. So when you initially look at this problem, you might not even think it's the difference of squares. Because even though there's subtraction and there's two terms, you can't take the square root of each term. There's no perfect squares in there. But remember, you always have to look for a GCF first. So if I look at my two terms, I do have a GCF. So 12 and 27, the GCF is 3. And then if I look at variables, x's, this guy's got an x, this doesn't. But when I look at the y's, this one has a y and this one has a y cubed. So I'm going to be able to factor out a 3y, a GCF of 3y, before I do anything else. So I'm just going to put a star there and just say GCF first. So I'm going to divide each of these by 3y. And that's going to leave me with 4x squared minus 9y squared. Okay, and again, if you don't need to write out the division step, you don't need to, but that's what I'd be left with. And then now if I look at what I have in my parentheses, now it looks a little bit more like the difference of squares. It's two terms subtracted, and I can take the square root of each term. These numbers are perfect squares. So what you're looking for is the numbers to be perfect squares, and then the variables to have exponents that are even. Usually we see the exponents being squared, but it is possible that they're to any even power. So now do not forget to take your GCF along for the ride. Don't abandon your GCF, bring them along. And then now I'm going to use a similar strategy like I did here for each of these. So the square root of 4x squared is 2x and the square root of 9y squared is 3y. Okay. So then I'm going to go ahead and set up my two parentheses. One of them is 2x minus 3y, and one of them is 2x plus 3y. And I am done. And again, if I wanted to check, I would just distribute. What I would suggest if you wanted to check this guy is distribute these first and then bring in the 3y. And remember, it should match your original problem. Okay, so just don't forget to look for GCF first. Now we're going to review trinomials when a equals 1. In other words, when the a value is 1. So just as a reminder, our trinomials are going to be in this form, ax squared plus bx plus c. So if your a is 1, so in other words, there won't really be a number there because it's an invisible 1, all you have to do is find factors of c, or your last term, that add to b, or your middle term. So we'll do a couple of examples to refresh you on that. So first one we're going to do is x squared plus 8x plus 12. So my a value is 1 because there's no number there. So, and I know in my class sometimes we wrote it out like this. It depends on who your teacher was. You might have written it differently, but we're going to look for numbers that multiply to be 12, or my C term, and add to be 8, or my B term. So the terms would be 6 and 2, because 6 times 2 is 12, and 6 plus 2 is 8. So then from there, I can go ahead and just write my solution. I know I'm going to have two parentheses. Since this is an x squared, I know this is x, and this is x. And then I just put my numbers in. So one of them is x plus 6, and the other one is x plus 2. If I wanted to check it, I would just have to distribute it out. And you'd see I'd get x squared plus 2x plus 6x, which would give me 8x, and then I'd have plus 12. Okay. So let's do a couple more like that. So this one, x squared minus 5x minus 24. Okay. My a is 1. And again, you still want to, just as a reminder, don't forget to look for a GCF first. Okay, there is no GCF. There was no GCF on this first one I did. There's no GCF here. So I'm just going to look for numbers that multiply to be C. So multiply to be negative 24, and then add to be B, which is negative 5. Okay, so we got to come up with the numbers. So 8 and 3 will work. And since we want this to be a negative 5, it's going to be a negative 8 and a positive 3. So then I'm going to go ahead and do like I did on the last problem. I'm just going to set up my parentheses. So I've got x and x to make x squared. And then I'm just going to plug those numbers in. X minus 8, x plus 3. And again, just as a reminder, these are interchangeable. In other words, I could write x plus 3 first and then x minus 8. Okay, because it's multiplication, it's commutative. And we are done. And we're going to do one more like that, x squared minus 6x plus 9. Again, look for a GCF. Don't see any GCF. So I'm just going to look for numbers that multiply to be 9, and which is my C, and add to be my B, which is negative 6. So the numbers that work are negative 3 and negative 3. So again, I'm going to write my two parentheses. I have x squared, so I know I have x, and then negative 3 and negative 3. So you may remember situations like this where when you went to factor the trinomial, the two factors wound up being the exact same thing. This is what we called a perfect square trinomial. So that just means there's an easier way to write our solution. Rather than writing it as x minus 3 times x minus 3, we can just write it as x minus 3 squared. Because remember, x minus 3 squared just means you multiply x minus 3 by itself. So this also helps you remember, these were called perfect square trinomials. In my class, I didn't really do them as separate trinomials. I just encouraged you to notice if something factored like that where they were both the same, just write it as it squared. Okay. So that's trinomials when a equals 1. And now we're going to review trinomials when a does not equal 1. Okay, so just a reminder, there's our format for trinomials, ax squared plus bx plus c. Now, when our a is not 1, so in other words, we have a number there, our strategy is we have to multiply the a by the c and then find factors of that add to b. Okay, and I'll highlight this when we do an example here. Then what we can't go straight to our solution from there, unfortunately, when the a is not 1. What we have to do from there is we have to rewrite the middle term using these two factors. And then lastly, we finish the problem by factoring by grouping, because after that we'll have created a polynomial that has 4 terms. Okay, so let's go ahead and do that with this example here. 6x squared plus x minus 2. Okay. So the first thing I'm going to do is look for a greatest common factor. I don't see one. And it's a trinomial where my a is not 1. So I'm going to multiply a times c. So I'm going to multiply 6 times negative 2. So 6 times negative 2 is negative 12. So I need numbers that multiply to negative 12 and add to be my b. So since there's no number in front of the x, remember that's an invisible 1. If you want to write it there to help you, you can. So I need numbers that multiply to negative 12 and add to be 1. So what's going to work is 4 and negative 3. Because 4 times negative 3 is negative 12, and 4 plus negative 3 is 1. So remember, the tricky thing on these is you don't go straight to your solution. What you do from there is, and your teacher may have called this splitting the middle term, we rewrite this middle term using these two numbers. So 6x squared stays the same, and then I split this term up using these two numbers. So I'm going to do plus 4x, and then minus 3x, and then minus 2. Okay, so these, you split the middle term using those two numbers over there. And sometimes people will ask, how do you know which order to put them in when you split the middle term? The order does not matter. Okay, you could have just as easily interchanged it and it will still work out for you. Okay. So once I've used those two to rewrite the middle term, split the middle term, if you will, now I've created a polynomial of 4 terms, so now I finish it by factoring by grouping, like we reviewed in the last video. So I'm going to put these two together and these two together and take out a GCF. So 6x squared plus 4x. So number-wise, 6 and 4, the GCF is a 2. And then x squared and x, so I can take 1x out. Okay. So I'm going to divide each of them by 2x. And that leaves me with 3x plus 2. I'm just going to write group off to the side there so you know what what we're doing after that. And then I'm going to do the same thing here. Now you'll notice I have 3x and 2, so there's actually not a GCF. They don't have anything in common. But what I do notice is if I don't take out a GCF, this guy's 3x plus 2, and this is negative 3x minus 2. So remember, when you're grouping, the parentheses have to be the same. So what I'm going to do here is I'm going to factor out a negative. I'm going to just factor out a negative 1 as my GCF. Why? Because that's going to switch the signs of both of these. This will turn into a plus 3x, and this turns into a plus 2. So now you can see 3x plus 2, 3x plus 2. So now I just go over here with my answer. So 3x plus 2 is my one factor, because that's what they both have in common. And then I write out whatever is in front as my second factor. So my second factor is 2x minus 1. There's my final answer. Of course, if I wanted to check it, okay, I know I sound like a broken record saying this, but you could check it by using the distributive property and making sure it matches your original. I would especially encourage you to do those on these ones where the a is not 1, because it's a lot easier to make a mistake. It only takes a second to check. So, okay, and we're going to do one more example here. Another one where the a is not 1. So we're going to look at 4x squared plus 22x plus 24. So remember, the first thing we want to do is look for a GCF. So here I've got 4, 22, and 24. So I notice those are all even numbers, so I know I'm going to have a GCF. All of these are divisible by 2. So the first thing I'm going to do is take out a GCF of 2. Variable-wise, they all don't have a variable, so I'm not going to be able to take a variable out. So I'm just going to divide all of them by 2. Again, if you need to write this out to help you, go for it. So this is going to leave me with 2x squared plus 11x plus 12. And now what I'm going to do is that 2, he's just going to go along for the ride, and I'm just going to factor this part in the parentheses. So the 2 just gets brought down. And then I'm going to use a similar strategy to this like I just did up here. So I have a trinomial now. My a is not 1. My a is 2. So off to the side here, I'm going to multiply a times c. So 2 times 12 is 24. And then I need factors of 24 that add to b, which is 11. So factors of 24 that add to 11. So I could do 8 and 3. Remember, don't go straight to your solution from here. Split the middle term. So 2x squared stays the same. Okay, and then this is where I split up 11x into plus 8x, using that one, plus 3x, and then plus 12. Then after that, I finish it by grouping. Group, 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 group. Okay, and that 2, just leave him out front. Sometimes that throws people off when you got that 2. Whoops, just go ahead and leave it out front. GCF of 2x squared and 8x. So they both have a 2. Okay, so that 2 I'm just going to put out front of everything. So I'm going to take out a 2, and then an x squared, and this one has an x, so I can take out a 2x. I'm just taking a GCF out of these two terms. So I'm going to divide this by 2x and this by 2x. So here, though the 2's will cancel, and I'm just going to be left with x plus 4. And then I'm going to do a similar thing for these two. I have a 3x and a 12. So 3 and 12, the GCF is 3, so I'm going to take a 3. So I'm going to divide each of these by 3. And that's going to leave me with what? X plus 4. Okay, and this is all of this is kind of in one parenthesis with the 2 out front there. So where do I go from here to write my final answer, right? Because it kind of tends to look a little bit messy, and you might tend to get stuck with what you do. I'm going to bring in another piece of paper here. Sorry to kind of go under here because I ran out of space a little bit. Okay, so for the final answer, what I'm going to do is that 2 just stays out front. Okay, so he just gets brought along. And then in here, you should notice I have x plus 4 and x plus 4. So just like we've been doing with grouping, those should match. So my one factor is x plus 4. And then my other factor is whatever was left over in front. So my next factor is 2x plus 3. And that is your final answer. Again, if you wanted to check, you could distribute. What I would suggest if you want to check is first distribute the two binomials together, and then multiply by 2. Should match the original problem. Just as a side note, like this is one strategy that will work every time for the trinomials when A is not 1, but I know that I mentioned to my class, and depending on who your teacher is, they may have mentioned it to your class. It is possible to do these problems with guess and check. Okay, so if you already have a strategy that you feel like works using guessing and checking, that's fine. You don't need to do it this way. This is just an option for people that want a go-to way that works every time. So, okay guys, so that's a review of factoring, difference of squares, and all the trinomials. I'll talk to you guys soon. Bye.